Hello guys, hope you all are doing fine. We are again here for a question from inverse trigonometric functions. This is a proving question. So let's see what does the question say. We have cos inverse of 4 by 5 plus cos inverse of 12 by 13 on the LHS and cos inverse of 33 by 65 on the RHS. So this is a pretty straightforward. If not for the NCERT, we could directly apply the formula of cos inverse x plus cos inverse y. But since we do not have any such formula in NCERT book, we have to go by the long method. And the long method is that we convert all the three terms. This one and this one and this one into tan inverse terms. So let's convert all the terms one by one into tan inverse. So first term is cos inverse of 4 by 5. Cos inverse of 4 by 5. Let me show it with the help of the triangle. We have cos inverse of 4 by 5. So this must be 4, this must be 5. So by Pythagoras, this is 3. So we can see cos inverse of 4 by 5 is directly converted into tan inverse of 3 by 4. Let's see what they have done. Okay, so what they did, they wrote cos x is equal to 4 by 5. Cos x is equal to 4 by 5. Then they applied the formula sin square x plus cos square x is equal to 1. They found out the value of sin x, and then they applied tan x is equal to sin x upon cos x, and they got their answer as x is equal to tan inverse 3 by 4. We directly did that thing with the help of our triangle. Now let's take the next term, that is this thing, cos inverse of 12 by 13. I'll show it on the next slide. So let's move on to the next slide. Okay, so now we have our next term as cos inverse of 4 by 5. Oh sorry, we already solved this thing. Now our next term is cos inverse of 12 by 13. Let's take the triangle approach. Our triangle approach says that cos inverse of 12 by 13 can be depicted as base is equal to 12 and hypotenuse is equal to 13. That makes it root of 169 minus 144. That makes it root of 25, which is actually is equal to 5. So we can directly write cos inverse 12 by 13 as tan inverse 5 by 12. The same 5 by 12. The same thing is written over here. So cos inverse of 12 by 13 is equal to tan inverse 5 by 12. Let's take the next term and the last term on the right hand side. The last term is cos inverse of 33 by 65. Cos inverse of 33 by 65. We have to convert it into tan inverse. So we again draw a triangle. Right angle triangle. This is right angle, and this was also right angle. Don't forget this thing. So this is right angle, and we have cos inverse 33 upon 65. That can be represented as base is equal to 33. Hypotenuse is equal to 65. Using the Pythagoras theorem, perpendicular is 56. So cos inverse 33 by 65 can directly be written as tan inverse 56 by 13. Tan inverse 56 by 13. Moving to the next slide. Now what we do? We take our LHS. Our LHS was cos inverse 4 by 5 plus cos inverse 12 by 13. Now what we do? We replace cos inverse 4 by 5 and cos inverse 12 by 13 into their respective tan inverse terms. tan inverse terms. Our respective tan inverse terms were cos inverse 4 by 5 can be written as tan inverse 3 by 4. Cos inverse 12 by 13 can be written as tan inverse 5 by 12. So we can see that now we can apply our formula of tan inverse x plus tan inverse y. I hope you all remember what is the formula. Let's see. Yes, the formula I am talking about is this one. We apply the formula. Our x is equal to 3 by 4, our y is equal to 5 by 12, and now we apply the formula. Moving to the next step, we get our simplified answer as tan inverse of 56 by 33. Tan inverse of 56 by 33, and we just actually proved that this was equal to RHS. So we have LHS is equal to RHS, and hence our problem is solved. I hope you all understood it. Thank you. Bye.